structure of the atom was in the structure that we kind of believe these days was initiated by Niels Bohr in the very early 1900s. It prevails today. There are modifications that have to do with quantum mechanics, which most people believe and some people doubt. But the essential model, which you learned and I learned and everybody learned pretty much, is pretty much intact. And that is, you've got a nucleus that contains protons and neutrons and some now subatomic particles. And you've got electrons or electron clouds that circle the nucleus. So it's been around for 5 generations. We all believe that since it's been around for 5 generations, it must be correct.
Yeah.
Right?
Yeah.
You believe it's correct.
I believe it's correct.
Yeah.
Change my mind.
Okay, well, I believe I might be able to change your mind in 5 minutes because we're talking about middle school concepts. We're not talking about complicated concepts. Okay, first point, nucleus. Nucleus consists of protons and neutrons, basically. Neutrons are neutral. We don't have to pay attention to them exactly. But protons are positive, and you squeeze a lot of positive charges together, and what do they want to do?
Repel.
Repel. So, and the repulsive force is actually much, much stronger than you think, and I can provide the evidence for that in a moment, and it's in the book. Much, much stronger, not just much stronger. Anyway, if you put all those positive charges and squeeze them together, the nucleus wants to blow up, right? So what prevents it from exploding? Well, the physicists did think about that. And they said, well, since we know the model is correct, there must be something that holds it together. And they invented a kind of glue to hold it together, which is called, quote, the strong force, which has become an essential feature of nature, a fundamental feature of nature, the strong force. This was invented, and it has just the characteristics so that it holds the nucleus together and it doesn't impact anything else. This was taken from someone's imagination.
Like Star Wars.
Like Star Wars. Yeah. There's no evidence for it. It's just, it must exist, you know. So if you like that, then you'll be happy retaining the model. But there's more. Now, electrons are negatively charged. And in middle school, I learned that negative charge attracts positive charge, right? Yeah. So you've got a positive charge nucleus, right? And around the nucleus are these electrons. And my understanding is that the two are attracting one another. So my question is, how come these electrons or electron clouds don't collapse onto the nucleus?
Yeah,
okay.
Okay. Yeah, because I would imagine that you would not, you're right. Yeah, you would not have an electron field around the nucleus because it would collapse in because negative and positives attract. Now, of course, that's my middle school understanding, of the way that the physics work.
It's valid. Your middle school understanding is like everybody else's, and if plus attracts minus, there's a big problem. Even Niels Bohr, when asked about the hydrogen atom, one plus, a nucleus, one minus, and electrons, or now electron clouds, he was asked, how come they don't coalesce? He said, they just don't.
They just don't.
They just don't. Now, if that's satisfactory for you, then keep the model. It's fine.
No, I don't think I am satisfied with that
anymore.
Okay,
so did I convince you in 3 minutes or so that there is a problem that needs to be addressed?
Yes, there's a problem.
There are many more problems that I don't need, almost as simple, that I expose in the book. And my conclusion is there's something wrong with the model, something fundamentally wrong, because it's not stable. Atoms need to be stable. This table is made of atoms stuck together. The table doesn't explode, and it doesn't collapse into a point, right? The table's there indefinitely. This one is more than 100 years old. It's been stable for a long time. So we need another model.
So are you suggesting, are you suggesting that matter, and maybe I'm extrapolating too far here, but are you suggesting that the material world we're looking at is not necessarily built upon atoms the way that we know them? Because there's another perspective of matter, and it's more of an energetic perspective of matter, that it is I don't know enough about it to get into it, but then there's the particle understanding, like matter is a thing, that comes together, like a bunch of atoms coming together to make the table, right? And the atom is like one of the most indivisible, or I should say the protons and neutrons should be one of the most indivisible, units of matter.
Yeah.
But matter is still a thing you can touch, right? Whereas energy or frequency, that's a totally different model or way of thinking about how material things, come into be. But if you're challenging the structure of the atom, are you also potentially challenging that there are a base unit of physical, like material thing that comes together?
No, I'm not challenging that. I've heard about the energetic argument. Frankly, I don't understand it. It doesn't make sense to me. Maybe it's correct. Maybe it's a limitation on my part. But I think of atoms in the traditional sense that they're the building block of everything we touch and feel and see. And the textbook version of it simply doesn't work.
Got it.
So therefore, either we stick with it and we continue to build on it, and science becomes ever more complex. When you build on a foundation that's not the right foundation, everything becomes incredibly complicated. And I believe that's where we are in science today. Extremely complicated. Mother Nature, this is my own personal view, it believes in simplicity. If we have a mechanism that comes from Mother Nature that is straightforward and simple, good chance it's correct. Good chance our understanding is what Mother Nature had in mind. If we have to twist our arms and legs in order to and scratch our heads to come to an understanding, my initial take on it is it's probably wrong, and we better start all over to figure out what might be right. I understand that it's a pretty radical point of view that I'm taking. I'm interested in truth. I'm in search of truth.
I can tell.
I don't like mechanisms that I really have to try hard to understand and can't understand them. And I find my colleagues don't understand them either. And we tend to believe, because they've been around for a long time, they must be correct. I don't believe that they're necessarily correct. I believe you got to start from foundational concepts and build from there.
I want to share what this podcast is all about. You see, I'm on this journey to design the healthiest home in the world. That's why I sit down with brilliant minds across biology, medicine, design, and more, all with one goal in mind: a home tuned to human biology. This is where I brainstorm, where we explore what it really means to create a home that heals. If that sounds like something you care about, hit subscribe, and let's see where this goes.